start applying that, right?
Yeah.
Correct. And applying it in a problem solving scenario, not in a normal. ठीक है, तुमको बोला 3 plus 5. Okay, let's say when you were a kid, when you were a kindergarten kid. Okay, you first learn counting, correct?
Yeah.
Then you learn another shortcut of counting, which is addition. Then you learn further shortcuts of repeated additions as multiplication. These are just operations, processes. This is how you calculate things, but that's not real maths. Okay, real maths is all about application. Correct. Okay. So you are on live, so keep smiling. Let's begin the class. One second. So you guys can see my screen?
Yes, sir.
Yes.
All right. So we had done till question 20. Our endeavor will be today to finish till question 23, and in next week we'll finish the entire paper. After that, we'll start with what we'll do is that every Sunday we'll pick up one topic, some topic, okay, and we will just discuss it and we will deep dive into those topics. Okay.
Okay.
Anyways, we are covering a lot of those topics while solving these problems also, but we'll just exclusively discuss those topics. Okay, so this is question 27. Okay, and this is the question. Okay, form two of two-digit numbers using 1, 2, 3, 4 without repeating any digits and using all of them once. Okay, so form two of two-digit numbers. Okay, what would be the minimum product of their sum and difference?
I didn't understand the part where they say form two of two-digit numbers.
Two of two-digit numbers from 1, 2, 3, 4. If we take one number as 12, we have to form another number with the digits 4 and 3.
Sudarshan, one second. Let me explain to her. Two numbers you have to form, two numbers, and each number has to be a two-digit number. That's it. So
Okay.
you have one number AB, another number is CD. That's it.
Okay.
And you have to use all the digits without repeating them. So obviously there are 4 digits, so you can split them into 2 parts.
Yeah.
Now you have to decide that what split you will take so that the product is what will be the minimum. The product is minimum for the sum and difference.
So you have to make sure that the difference is quite close. So first what I had done was I took like 41.
Difference is 1 second. Difference is close or difference is more?
The difference should be close.
Close or more? Think about it.
Sir, close.
Think about it.
No, sir, if you...
Product is minimum, Babu.
Yes, sir.
So in a rectangle, let's say there's a square and there is a rectangle and their perimeters are equal. Okay, let's take a rectangle and a square whose perimeters are 20, for example.
Okay, so the square will have side length 5, so the area will be 25. And if we keep 9 and 1, we have 9. So the difference should be more.
Mr. Sudarshan, don't do ulta pulta.
Yes.
Correct. Closer the numbers, the product is more, correct?
Yeah. So we have to keep them very far.
Maybe we can take 43 and
43 and 12. Yeah, 43 and 12.
1 second. So for 1 second, first of all, for two numbers to be this thing, products to be very close, I mean to be minimum, the numbers themselves need to be small enough, correct?
Yeah, so it could be like 23 and 14. 23
and you have a sum here, correct? So you have to minimize the sum first. First you have to minimize the sum. Now let's look at this. For minimizing the sum, the numbers themselves should be smallest. So you can either take a 1 and 3. So you in the tens place, you will use the smaller digits, correct? In this case, what is happening? You notice that the sum is still 37, correct? And if you switch the ones, and you say a 14 and a 23, you will still get a 37.
Yes.
Because you are adding the ones and you are adding the tens. The same ones and same tens. Just swapping their place, correct?
But in the 13 and 24 case, the difference is more. So we would probably opt for that.
Correct. And in this case, the difference is only of 9.
Yeah.
Correct. So let's try this. So 23 into 14, 23 into 10 is 230. And 23 into 4 is 92.
92.
Right?
So
Right?
920.
322. 320.
Correct.
Yeah.
Right? 230 plus 92. Correct. So you will get a 322. Right? In this case, understand this. You have a 24 into 13. Correct. So now let's look at this 240 plus a 24 into 3 is a 72. What do you get? You get a 312. Do you see this?
Yeah.
And that is your answer. This one is your answer. Why? Because the gap here is more.
Okay.
So a lot of logic applied. One is that we have to minimize the sum. For that, we will use the smaller digits.
Yes.
And then for the difference, I mean, for the product to be minimized, we have to take the larger difference. So therefore, we will put the smaller digit here and the larger digit in this one, because then only you have a 20 here. You have a 20 here, right?
Sir,
So,
but they are asking for like the minimum product of their sum and difference. So you took the product of the numbers.
yeah. Oh, sorry.
You need
Sum
to
and
take the
the
product of the sum and
Yeah, you
difference.
have to the minimum product of the sum and difference.
oh, sorry. Yeah. In that case, it should be yeah, my mistake. So that's 37 into 9.
Yeah.
Yes.
We will
So
use
that is
this. Sorry.
333. Yeah.
Yeah, I actually, yeah. So this is not about finding their product, but rather
Yeah.
this one. So 37 into 9,
9.
it will be 9.
Sir, that's what I had done 14 and 23. So that's what I had told earlier.
Oh, okay, okay. Sorry. So my mistake, my mistake. 37 into 10 is 370 minus 37.
Yeah.
What will we get here?
407.
407.
No, sir,
We're
Sorry,
subtracting, right?
what is
We're
sir,
300
subtracting.
and
yeah, we are subtracting. Oh, so
So it will be
333. 333. That's what I was confused.
333. Okay. The sum has to be minimized, and then for that minimum sum, what is the minimum difference? So minimum difference will be this one. So
We are
yeah, for
looking at
minimum
numbers
difference,
that are close, like that are small, but they still have a like large difference, right?
yeah, yeah. So the numbers will be difference will be low when the higher number has the smaller number has is closer to this point, and the larger number is closer to this point. So therefore you use the larger digit with the smaller 10 and the smaller digit with the
So wait,
larger
then
10.
that means they have to be closer together because when we took the example of 13 and 24, they are giving the same
Oh,
sum, but they are more, but we are not taking that because it will
no,
give
no.
like
So it was my mistake. I didn't understand the question properly. The question is minimum product of sum and difference. So this has to be lowest, and therefore this one also has to be lowest for this case.
yeah. So the difference has to be smaller.
Correct, correct, correct. Okay, so let's do the next one. Let's do this. The remainders when a number a is divided by 4, 10, and 18 are 1, 5, and 9 respectively. Find the sum of all possible values of the remainder when a is divided by 7.
So like it can be like 45 when we 45 divided by 4, you get 44 which is divisible by 4 and 45 like 40 which is divisible by 10 and 30.
How are you getting the answer so quickly? Which in the numbers? You solved the paper already.
Yeah, so I'd solved the paper. I'd solved it yesterday, sir.
That's why it's fresh in your memory.
So I
Okay, so
thought
guide.
the questions were supposed to be different, but then it became the same questions. So
Tell me, how will you go about finding the first of all
yes, sir. So
the
first you have to see 45, and so
Why
45.
did you go by 45? Why did you go by 45?
So I just did like a trial and error. So
So
first it
in
has
this
to
the
be divisible by 5 first of all, and it can't be divisible by 10, and it has to be divisible by 9. So I went with 5 into 9, which is 45. So that's what I did.
and it has to be divisible by 9 also.
Yeah, it not 18. It doesn't have to be divisible by 2.
So what we will go, we'll look at odd multiples of 9, which are multiples of 5 also.
Yeah, yeah. So 45 is the first one.
Yeah, 45. And when we divide it by 4, we do get a remainder of 1. When we divide by 18 also, we get a remainder of 9. When we divide by 10 also, we get a remainder. So 45 becomes your first number. And therefore, when I divide 45 by 72, and in this case, Sudarshan, you won't speak. Itishika, what is the remainder here? When you divide 45 by 72?
The remainder will come. Wait.
The remainder is, Itishika, the remainder is 45 itself. Understand what is the remainder. So when you divide by something, when you go jump by the divisor, okay, when you can't take another jump, full jump, and you cross that number, okay, therefore from the previous multiple, this part is called the remainder, correct?
Yeah.
So in this case, because 45 is small, so you cannot take a full jump itself, correct?
No.
So 45 is here and your 72 is here, the first jump. So you take zero jump, zero selection. So your quotient is zero and the remainder is 45 itself.
Oh. Okay.
That's how it works.
Yeah.
Correct or not? So when you divide, for example, let's say if you divide 10 by 4. So 4 will jump 2 times properly till 8. And then you cannot take another jump because then you cross
So
the
the
10.
remainder will be
Correct?
2.
So the remainder is 2. So in this case, the jump is 0.
Mm-hmm.
Therefore, it's 45. That's how it is. So see, these are the concepts which teachers in school don't teach. And I get really mad because of this. These are very simple concepts. Correct. You need to understand the remainder not just by mugging up that this is remainder and this is the definition of remainder. Remainder is always smaller than divisor. This is not KBC, right? You have to use this in problem scenario. Okay, so 45 is the first number. Now what will we do? Sir?
Yes, sir. So now, so were you talking to me?
Yeah, I'm asking you, yeah.
Okay. So now we have to find all the different possible values of the remainder when a is divided by 72. So we got a first possible value as 45. So now we have to find another number that will give like the same kind of reminders. So for this, I did the LCM of 4, 10 and 18 and added it to 45. So it would give like the same kind of.
Yeah. So what happens? Why would you give the same kind of remainders? Let's understand this. So for example, let me just explain. Okay. So let's say if I'm saying there is a number which you divide by 3, you get a remainder of 2. When you divide by 5, you get a remainder of 1. Okay. Okay. Now the smallest number in this case is going to be your 11. Okay. Let's understand this. So you just do a little trial and error. Okay. If you divide a number by 5, you get a remainder of 1. If you take the first number which will, when you divide by 5, you use your remainder of 1, that is 1 itself. But when you divide 1 by 3 also, you get the same remainder 1. Correct? So 1 doesn't work. Then you will try the second number by 5, which is 6. When you divide 6 by 5, you get a remainder of 1. But then it is completely divisible by 6. So that also doesn't work. Then you take the second multiple of 5 plus 1, which is 11. And then you divide it by the next one. And you see the remainder is 2. So 11 is your first number. So what happens? At 0, the 3 started jumping. It jumped 3 times. And at 11, it gave a remainder of 2. Correct?
Yes.
Right? The 5 jumped 2 times. Okay, sorry, my drawing is not that great. One second, let me just make it a little better. So the 5 jumped 2 times and it gave a remainder of 1.
Yes.
Correct? This phenomena happened at 11 when they both started jumping at 0. When they were together. Before, in between, they never met. Correct?
Yes, right.
The next time they will meet again will be at 15, which is their LCM. Correct? And the same pattern will start repeating from here.
Yeah, so we have
after 15, again after 15 plus 11, it will again the same thing will happen. That means at 26, the same thing will happen. You divide 26 by 5, you get a remainder of 1. When you divide by 3, you get a remainder of 2. Understood? Okay. And at every LCM plus 11, this will keep on happening. Every multiple of LCM. Understood? So 26, then 30 plus 11 at 41 also this will happen. Then again at LCM 45 plus 11, 56 also this will happen. All these numbers. Okay. So same funda he's applying. He's saying that 4, 10, and in this case there are 3 numbers. So he's taking the LCM of all 3. So how do you take the LCM? We'll use the prime factorization. 4 is 2 into 2. Okay. And the 10 is 2 into 5. And the 18 is 2 into 3 into 3.
Yeah.
Right? So we have the largest 2 is here. So we take the largest 2. The largest 3, there is only one 3. So we take the 3 and we take the 5. So we get what? 4 into 3, 12 into 5, which is
We have to take another 3, no?
Which one?
So because 8
sorry, there are 2 3s. I did not notice. Yeah, there are 2 3s.
180.
Yeah, so
So you got 4 into 5, which is 20. 20 into 9, 180. Correct.
Yeah.
So 180 is your LCM, right?
Yes.
Then 180 plus 45, which is at 225. 225, this phenomena will again happen. Okay, so let's divide 225 by all these numbers and just check it. So if we divide it by 10, we get a remainder of 5.
5.
If we divide it by 9, 18, we will again get a remainder of 9 only, I guess.
Yeah.
And all these things will happen. Okay, we know that will happen. Okay, at 225. Okay, but when we divide this by 72,
So 72 into 3 is 216.
216, correct?
Yeah.
Therefore, we'll have a remainder of 9.
9. Yeah.
So my possibility 2 is 9.
9.
Okay. Then let's understand. When we double this, 180 double this, now we go by multiples, right? So we get a 360. Okay, and plus a 45. Okay, so we get what? 405.
500. And yeah.
405.
So now we get the remainder is 45.
The remainder is again you will get a 45. Why? You know 45. Why this will happen? Because 360 itself is a multiple of this.
72.
72.
Yes.
Yeah.
Okay. So therefore you will again get a, so now it will keep on going in cycles. So 45, then again 9, then again 45, then again 9. So there are only 2 possibilities. 45 and 9, therefore their sum is 54.
Yeah, I like that. I like this question.
Let's do this one. The teacher wants to distribute all 48 candies he has to the students of his class. At most, how many students are required in the class to ensure that at least one student will end up getting 4 or more candies?
So I had done this question, but I'll wait for her to solve it.
I didn't quite get that. Can you show it?
So understand this. This is called pigeonhole principle, and based on that, this question is there. Now understand this. What is going to happen? Okay. Let's say there is only one student. One student. You give all the 48 to the person.
Yeah.
Correct. Let's say if there were 2 students.
I would get 24.
No, I'm not saying equally divided. Nowhere it says that it has to be equally divided. Correct.
Yeah.
Okay. So let's say whatever. Either if you do equal distribution 24-24, and if you look at the extreme opposite, I can have a 0-48 also.
Yeah.
Correct. So even if you have a 0-48, you are seeing that at least one person is getting 4 or more. Correct.
Yes.
Right. Now let's look at this. Let's say I have 20 people. Okay, so there are 20 people. I'll just give you an example. Let's say there are 20 people.
Yeah.
Okay. And I start giving 2 each. So I exhaust 40 chocolates, correct?
Yep. I'm still left with 8.
Still left with 8. So I can give 8 more people like this, till eighth person.
Mm-hmm.
One more. I still am not getting, I'm not able to give 4 to anybody, correct?
Yeah.
Okay. Okay. It
Mm-hmm.
does not, see, there are 20 people. I am not saying that we can still give to one person only, I can give 48 and the rest 0.
Yeah.
Correct. But what if I decide that I don't want to reach 4? I don't want to reach 4 per person, but for any person. What I will try to do? I will try to distribute the chocolate as equally as possible. Correct. So that nobody's count goes high. Correct.
12?
I'll first give, so that nobody's count reaches 4. Correct. So what I'll do, I'll try to exhaust my chocolates by giving one first, then another one first, and then another. So what is happening? Nobody reached 4. Correct.
Okay.
Understood or not?
Mm-hmm.
Nobody reached 4. So, so with 20 students, I cannot guarantee that at least one student will end up getting 4. So it has to be a lesser number. Are you getting my point?
16?
Yeah, correct. Exactly. 16 students. Why? Because let's say you have 15 people.
Yeah.
You have 15 people. Okay. So you divide 48 by the number which is less than this by
By
3.
3.
So you get 16. Okay. 16 people. Okay. So if you have 16 people, okay, what will
Mm-hmm.
happen? Actually, the answer is not 16. The answer would be, in this case, would be 15. Okay. You
Okay.
divide 48 by 3, so you get 16. So if you give 3 to each one of them, you
Mm-hmm.
exhaust your chocolates, correct?
Yep.
So if you have one lesser person, if you have only let's say 15 people,
Mm-hmm.
and you apply the same strategy, you start giving 3, okay, you will end up getting 45. Then there will be 3 people who will, even if you give one, they will get four chocolates.
Yes.
Understood? So it is
Yes.
saying that at least one student will end up getting 4 or more candies.
Yeah.
But no matter how you distribute, if you have 15 people, okay,
Mm-hmm.
at most, he's saying. The
Mm-hmm.
moment you go beyond 15, you go 20 people and all that, more than 15, you can then distribute lesser chocolates. Because there are more
Yes.
people, then you can distribute lesser number of chocolates to each one of them. And therefore, nobody will end up getting 4. Correct?
4 or
The
more.
maximum number you can have is 15.
Yep.
Understood? Because the 15 will ensure, guarantee that at least one person will get.
Yeah.
Yes.
Okay? So
Question
that's the
is,
answer. Okay. Okay. Now let's do grade 8 paper. We've done to question 23.
we're left with 2 more questions, right?
Yeah, for next week. I don't have the time today properly. So, I would have finished this. Okay, a 7 by 7 square is made up of 49 1 by 1 squares. Okay. The large square has one asterisk in each of all the 4 corner small squares. How many rectangles in the large square do not include even a single star in them? Let's do this.
So the total number of rectangles that can be formed first from the 7 into 7 square would be 824, right? The rectangles. I mean, no, I mean 784. 28 square. Because it's 8 choose 2 into 8 choose 2.
So you're on mute.
Yes, so you're on mute.
Sorry about that.
So 8 choose 2 is 28. So 28.
Yeah. So you need not do 8 choose 2. I know why you do 8 choose 2 because you have 8 lines here, correct?
And then you can choose any two of them as like
So
horizontal.
for any rectangle, you need 2 vertical lines and you need 2 horizontal lines. So how many combinations you have? 8C2 here, 8 choose 2 here. I prefer an easier method, which is I see 7 boxes are there, right? So 1, 2, 3, 4, 5, 6, 7. I do a 7 into 8 plus 1. That is 7, n into n plus 1 by 2. That's the same thing. So understand this. What happens? The number of boxes, let's say, is m. Okay. Sudarshan.
Yeah.
Then your lines are n, which is m plus 1. Correct. Right. So when you do a n choose 2, you do basically a n into n minus 1 by 2.
Yeah. So what is n and m here? N is the
number of boxes, the number of columns, and n is the number of lines. The number of lines will be always one more, correct? So,
yeah.
So you have one box, you will have 2 lines, correct? So if you have 2 boxes, you will have 3 lines, correct?
Yeah.
Understood. So n is n is the number of lines, which is m plus 1, right? Number of boxes plus 1, correct? N choose 2 is n into n minus 1 by 2. This is what you use, right?
Yeah.
Right? Now look at n. N becomes m plus 1. From here, if you substitute it, m plus 1. And n minus 1 is m itself.
Into m, yeah.
And this is the formula for what? 1 to m, correct?
Yeah.
1 to m. So 1, 2, 3, 4, 5, 6, 7, 8. M into m plus 1 by 2. Same thing. Understood or not?
Yeah. But using lines, it's a little more obvious because in a rectangle, there are 2 horizontal lines and 2 vertical.
Yeah, but even this also, I will explain the logic behind this.
Yeah.
Let's say if you start from here, your leftmost line is this one. Then on right, how many choices you have? You have 1, 2, 3, 4, 5, 6, 7.
Yeah.
That 7 comes here. Okay. Then you start from here. Then you have 1, 2, 3, 4, 5, 6. Okay. So the 6 comes here. Then you start from here. Then 1, 2, 3, 4, 5. The 5 comes here. Like that. If you go, when you take the last one here, the leftmost line, then you have only one choice, this one, right? So therefore, 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. The same thing.
Yeah.
Understood or not?
Yeah.
Okay, cool. So anyways, so we know this is 28 and this is also 28. So 1 to 7 sum is 28. So total number of rectangles is 28 into 28, which is 784. How much is that?
784.
784. Okay. But our problem has a different thing altogether, right? Our problem is saying that we have asterisks here in the corner ones. And we are saying how many rectangles now do not include any one of them. So it's very simple.
So first I thought if we get the number of rectangles, like total number of rectangles and subtract the ones with the crosses, that will give the same answer.
But instead of doing that, because see, some of the rectangles will include 2 of them and some of them will include all 4. Some of them will include only 1. There is no rectangle which will include only 3. Only 3 no rectangle can include, correct, in this?
Yeah.
Logically, the way you look at it, right? Any rectangle will either include 1 only or 2, like this or like this, like this or like this, or like this or like this, correct? Or it will include all 4, which is the bigger rectangle itself. So that is only one rectangle.
So what you can do is actually make it like into a 5 into 7 rectangle, 2 5 into 7 rectangles.
So let's understand this. All the rectangles which fall here between these 2 lines, and all the rectangles which fall here,
are
these 2 lines. Yeah. Okay, you calculate that, and then you take out the common part.
Exactly. So you subtract it once, so it will give you.
It's double counted, right? So here you have 5, and here you have 7, correct?
Yeah.
So you in this the vertical rectangle which we see here, this one, Okay, we have 7 of them. So 1 select is 7, so that's 28. And to 15. How much is that? 28 into 15. So let me just change the increments.
Sir, 420. 420.
420, right?
Yeah.
Similarly, by symmetry of this figure, this one will also give me 420. By symmetry
Yeah,
of
420.
sheer symmetry of the figure, right? So I'll have 420 plus 420.
So now you have to subtract like
840.
from a 5 into 5 rectangle, how many? So
Correct. And that is going to be
6
15 into
choose 2
15.
into 6 choose 2.
Yeah, 15 into 15, right?
Yeah, exactly.
1, 2, 3, 4, 5. I just not told you.
Yeah.
15 into 15 is 225.
25.
You subtract 225 from it, you get 615, and that's your answer.
Yeah. Cool question.
There are 615 of them. It's not so cool. It's a very common, easy question. Okay, so let's go to the next one. I'll tell you what will be a cool question. I'll tell you. Okay. Now understand this. If I give you a question like this, okay, which you will get in AM1, HKM1. Okay. Let's say this is this thing. Okay. And if I tell you that there are, okay, now find out how many rectangles,
Sir, no, please.
how many rectangles does not include any one of them. This is a cool question. Okay. We'll discuss these kind of topics. Once you understand that how to work on these topics, you'll find these very easy. Okay.
Yeah.
Okay, we will explore that. So in this also, what we do, basically, we know in this case, can there be a rectangle which includes this one and this one, but does not include this one? Can there be a rectangle? No.
No.
Correct. So we will first say that, okay, let's count all the rectangles which cover only these two. That we can count, right? Lines to the left, lines to the right, lines to the top, lines to the bottom. Correct.
Yeah.
Multiply all of them, we get the rectangles which will contain both of them. Correct.
Yeah.
Right.
So
Then we we will count for these two. Correct.
So how do we count the number of rectangles which will have those two?
You don't know this. Okay. So for any object like this. Okay. Okay. So let's say you have a cross here. Okay. I say how many of the rectangles will contain this in this one. So understand this. A rectangle is made up of a combination of horizontal lines and vertical lines. Correct.
Yeah.
So you will count how many vertical lines are there to the right. To the right, there are 2 of them. We can see. To the left, there are 1, 2, 3, 4. So left is 4. Correct. Top is 1 and 2. Correct. And bottom is 1, 2, and 3. That's it. You just multiply all these numbers because it's a combination of all these. You have a shirt, you have 2 shirts to wear, you have 2 pants to wear, you have 2 hats to wear, and 3 shoes to wear. How many combinations you will get?
So 2 into 4 into 2 into 3. Okay.
That's it. So that's, I think 6 into 8, 48. 48 rectangles will be there, which will contain this. Because you will pick one line from these two, the ones which are on top, correct? You will pick one line from the left, and you will pick one line to the right, and one line to the from the bottom. And that combination, every unique combination is a unique combination, is a unique rectangle.
So how the 2 ones are from the left? So 1, 2, and then
the 2 ones are from the right. 2 ones are from the right. This is right.
Okay, so this is
This is left. This is top. This is bottom. Bottom below the. See, the lines have to be below the square to contain it. Correct.
Yeah.
See, you have to choose one of this, and one of this, and one of this. Correct. And here you have the cross here. Correct. Here you have bottom. You have 3 choices. You can pick any 3. It will still be inside it. Correct.
Yeah.
Right, left, right. You have 2 choices. Left, you have 4 choices.
So I understood. So over here,
top you have 2 choices.
1, 2, 3, 4. 1.
So how many combinations you can make? You have 2 shirts to wear, 2 shirts to wear, 3 pants to wear, 2 hats to wear, and 4 shoes to wear. Shoes.
So then you just have to do 3 into 4. So why did the 2 come? Like the 2, like.
You have to take all 4, na babu.
But where did the 2 come?
Yeah, even I am not sure where the
Which two? Which two you are talking about?
So the right two and the top two. So what
Yeah.
Yeah, so there are two lines now on top of it. If the cross is here, one second, the cross is here. How many lines are there? There is one line here, there is one line here.
Oh, so now it's about the horizontal, like.
There are two top horizontal lines. This is the top lines. These two top lines, two top lines. There are three bottom lines. Correct. I just showed you three bottom lines.
Okay.
Right?
Yeah.
One, two, and three. Right, there are two of them. Left, there are four
Oh,
of them.
okay. So the two lines can be the starting horizontal line, and the other three can be the ending ones. So okay.
Exactly,
Yeah.
exactly.
I
So
understand.
if you pick up this one, you have three choices at the bottom. Correct.
Yeah, yeah, yeah.
Yeah.
Similarly, when you pick up this one, you still have three choices. So 2 into 3. And
Okay.
for each of these combinations, you have again like 4 into 2, 6 choices.
Okay.
4 into 2, 8 choices. Correct. You
Yeah.
take one left line, you take one. You have two choices. Then you take this one, you take again, you have two choices. So
So
there are overall. I'm just saying.
okay.
Let's forget all that. I'm just saying. You have 4 shirts. Okay. You have let's say 2 pants, 3 shoes, and 2 hats. Shirts लेगा पर t-shirt कर देते हैं. ठीक है. When you wearing, okay, you have a one t-shirt. You take one t-shirt. Okay. Then you have 2 pants. Correct. And let's say you take this pant with this one. Okay. And with this pant, you will have 3 shoes here. So shoe, shoe, and shoe. Correct. Here also you'll have shoe, shoe, and shoe. Okay. Okay. And
Yeah.
then you have 2 hats with each one of them. This is very basic. I should be teaching you these things. You should know that combinations कैसे काम करते हैं.
Yes.
Whenever it is and, so this one will have hat and hat, and this one will also have a hat. And look at this. So you got how many? 2 plus 2 plus 2, 6. These are all different paths, right? So the end को अगर आप map करोगे, how many you got? Okay. With one t-shirt, you are getting 2 plus 2 plus 2 plus 2 plus 2 plus 2. Like that, you have 6 into 2. You have 12 here, correct? With one t-shirt. Now look at the t-shirt 2 and t-shirt 3 and the t-shirt 4. They will all have this kind of tree. Correct or wrong?
Yes, sir.
And you can start with anything. You can start with the t-shirt also. You can start with the pant also here. The trees will look different. That's all. Itishika is still confused. Confused, na? Are Itishika, I will explain to you. Itishika, I'll just explain to you. I won't get into too much of this thing. Okay. Let's say Itishika has got 3 t-shirt. T-shirt 1, t-shirt 2, t-shirt 3.
Okay.
Okay. And you have pants also. You have a pant 1 and a pant. How many combinations you will wear? Will you wear 3 plus 2 or 3 into 2?
Mm-hmm.
How many combinations you can make? Think about it. And with the t-shirt 1, this is one combination.
Yeah.
With the t-shirt 1, you can wear a pant 2. This is a second combination.
Yes.
Then again with this one, you will have a P1, you will have
6.
another one. P2. It's always whenever it's and it's 6, 3 into 2. Same thing I'm doing. We have 4 things here. Instead of 2 things, in this one, we have 4 things. Even if there are 3 things same, let's say I take this one, I take this one, and I take this one, and this one. But in the second combination, I take this one, this one, this one, and this one. These are 2 different combinations, no? That correct or no?
Yeah.
There are 2 different rectangles. I have the topmost line, I have the leftmost line, I have the rightmost line, and the bottommost line. So that becomes the biggest triangle. But the moment I change this line to this line, now my rectangle becomes like this. This is a different rectangle than the whole rectangle, correct? So therefore, you have to multiply these because it's all and. I am taking one from here, one from here, one from here, one from here. Correct. I have 2 burgers to choose from. I have 4 types of French fries to choose from. I have 2 cold drinks to choose from and 3 ice creams to choose from. How many different combinations I can make? It's on a product, correct? Never added up, right? And if you don't know this, then I don't know what your teachers are teaching you in school. Seriously.
So right now in our 6th standard, so we are Like
No, but
learning.
this is a very basic thing. See, these things you need to learn from childhood. Correct.
Yeah.
That whenever there is a scenario of and. Okay, let me just give you another example just for and for. Okay. Last time also I gave it, I think. So let's say you're going from point A
Mm-hmm.
to point B and you have three routes. Okay, and from point B to point C, you have two routes. Okay, so how many routes are there altogether from A to C via B? There are six routes because this is and. You have to go through A, B, and then B and C. Correct. So let's say this one is AB1, this one is AB2, and this one is AB3, and this one is BC1, and this one is BC2. Okay. So how many combinations? I will have a AB1 with a BC1. Then I can also have a AB1 and a BC2. Correct. Similarly, I can have a AB2 with a BC1. I can have a AB2 again with a BC2. And similarly with AB3, a BC1 and a AB3 and a BC2. So I have six, 3 into 2. Correct. This is an AND scenario. I am going from A to B and then from B to C. And now this is a OR scenario will be different. Let's say if I say from A, you're directly going to C. Okay, there are three routes. Okay, AC1, AC2 and AC3. Okay, and from B, there are again two routes. But A and B are not happening. This is OR. Either you start from A or you start from B. It's not happening together. It's an OR scenario, correct? To reach C, either from A or B, what will you do? You will say that there are five routes, correct? So three over here and two over here. So this is 3 plus 2. Why? Because it's an OR scenario. If you have two t-shirts to choose from, okay, what will you say? Two t-shirts to choose from. You have one t-shirt and another one t-shirt. So you add it up, right? You say, okay, either I wear this one, or I wear this one, or I wear this one. So it's OR, correct? अभी भी नहीं समझ में आया?
Sir, yes, I understood.
Okay, मुझे लगता है ड्राइंग करके समझाना पड़ेगा. One second.
So what?
ड्राइंग करके समझाना पड़ेगा. Okay. Is it a t-shirt?
No, sir, I understood.
नहीं इतिशिका को नहीं समझ में आया ना.
Oh.
One second. Three t-shirts.
Yeah.
Okay.
Yeah.
All right. And two pants. One is a black one, and the other one is a blue one. Okay.
Yeah.
Now, here I'm adding up. Why? Because that you can either wear this one or this one or this one. So I'm saying you are adding up. So how many t-shirts you can wear? I can wear three t-shirts. That is 1 plus 1 plus 1. How many pants you can wear? I can wear. But when I'm saying and, how many combinations you can wear? This is a combination. So with this one, I can make these two combinations. Correct?
Yeah.
Similarly, with this one, I can make these two combinations. Correct? And with this one also, these two I can make. So
Yeah.
what is happening? What is happening? 1 into 2 plus 1 into 2 plus 1 into 2. Correct?
Mm-hmm.
Right? So I will take the 2 common. 2 into 3, that is 6. Correct? This we are multiplying basically. 3 into 2.
Yeah.
Understood or not? So whenever it's a and scenario of choices, chicken burger, mutton burger, veg burger, 2 French fries. Okay,
Yeah.
peri peri and classic salted. Correct? Again, इसके साथ भी peri peri, classic salted. और इसके साथ भी peri peri and classic salted. What is happening here? 3 burgers and 2 types of fries. What do we end up with? We end up with 6 combinations. This is one combination. This is second combination. This is third combination. This is fourth combination. This combination. This is sixth combination. Correct?
Yep.
Understood. So whenever it's an and scenario, it's a multiplication. Now understand this. Within these choices also, if you look at it, it's an addition of 6 choices. So this or this or this or this or this or this. So in this case, we are adding 1 plus 1 plus 1 plus 1 plus 1 plus 1. Or whenever we are saying or and. There are 6 choices. Okay, so anyways, Let's do the next one.
So it's 6:15.
Yeah. So you have to go.
Yeah, I have class.
What time?
It's gymnastics.
What time? What time?
6:30.
Who has a class? Idishika.
Yeah, I have a class.
6:30 our class. Which one?
And
Okay. Gymnastics. You learn gymnastics?
yeah.
Arey Baba.
I
So,
tried once and it was not a good experience.
someday, show me. Okay. Anyways, so can you do that? Can you just wait for this question and then we will finish it
Yeah,
at 20.
sure.
So Sudarshan, just make a note that in grade 7 we have done till question 23, and grade 8 we have done till question 22. So let's just do this one and then we'll leave. Okay, this is again a very interesting problem. A tourist starts from town A on Monday morning and he can go any of the nearby towns B, C, D, E. Okay, subsequently, every day in the morning he goes out from one town to another town out of these 5 towns. He reaches the next town on the same day by afternoon. Okay, so in the morning he starts, in the afternoon he reaches, he stays for the whole day over there, in the night also he stays in a hotel. Next morning he starts again for another town. Okay, it is not necessary to go to each town, and he can also revisit the same town on any another day. On the same day he cannot go because from one town he has to go to another town. But he can again come back to his home, that town on the next day if he wants to. So he can revisit a town. If he lands up in town C on Thursday afternoon and comes back to town A on Sunday afternoon, how many different possible routes? Assume one route from one particular town to any other particular town are there for the 7 days. Assume that he reaches from one town to another on the same day in a few hours. So he starts in a Monday morning. Okay. So let me explain to you that how this problem is classically called as passing the ball problem, and how many ways a ball can be passed. Here the tourist is being passed from one town to another town. Okay. So we have how many towns we have? Let's write it down. Okay. A, B, C, D, E. Have you done this one, Sudarshan?
Sir, I only did the 7th paper because I thought the 8th was little difficult.
Okay. Don't worry, we'll just go. Let's say this is Monday, this is Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. This is classically called a passing the ball problem. Okay, you will understand this one. So on Monday he starts and he has to go. So we will here in this map we are going to plot in which towns he will reach on the afternoon. We would not plot from where he's starting. Okay. So on Monday, definitely in the afternoon, he won't be in A, correct? Because he was in A and he started from A. So he would have left A, correct?
Yeah.
So you got to put a 0 over there. And then he can go from A to B. So he can come from A to B, A to C, that's one route. AD. So understand this. What I'm doing basically, this one stands for AB route. So I wrote the first 2 letters of a route. Okay. The next one is AC, the next one is AD, and the next one is AE. So hence you got a E, 1, 1, 1. Did you understand so far?
Yeah.
Yes.
Okay. Now understand this, that how this one works. Okay. Now he can come from on A, he can come from here, he can come back from here, he can come from here on Tuesday afternoon, he can reach back A from all these 4, correct? So you will
Yeah.
put a 4 here. So you add basically the previous day's all others numbers, not its own number, but all others number, you add it up and you write it over here. Understood? So this
Yeah.
means that this 4 stands for here ABA, ACA, ADA, AE. Okay. For the B here, okay, and you already had a AB, फिर से इसको लिख देते हैं AB, AC, AD, AE. They are already there. Okay, these are already there.
For
Now,
B, there would only be 3 possibilities, right?
B will be coming from, because it cannot come from A obviously. Okay,
Yeah.
because
So
A
there'll be
was
2
not there.
possibilities.
So the remaining whatever you total it up. That's all. That's the only funda in this. So you add it up, you get a 3 here. Similarly, for C also 3 here, also 3 here, also. So
Yeah.
basically, in this one, for example, this 3 here will stand for ACB, ADB, and AEB. Not this one, sorry. And similarly for all the others also it will stand this way. Okay, for the C1 it will be AB, ABC, okay, and then ADC and AEC. And for the D1 also it will stand like that. AB, ABD, ACD, and AED. And for the E also it will stand as A, AB, ABE, AB, sorry, ACE, and ADE. You notice here, these three are for this one, these three are for this one, these three are for this one. So now see how many combinations? 4 plus 3 plus 3 plus 3 plus 3. Correct. That's exactly what you see here also. Correct or not?
Yep.
These are all the different routes till here, till Tuesday. The same fundamental we're going to use. Now, इसमें एक और चीज है, बोलता है कि Thursday afternoon he comes to town C. So if he comes to town C for sure, then he was on Thursday afternoon, he was not there in any of the cities. That is a condition of a question, which means you put a 0 in all of the rest. Understood? Understood or not?
Yeah.
Yes, sir.
Because Thursday afternoon he reaches town C. At the same time, he cannot be in town C on Wednesday afternoon.
Okay, yeah.
Because how will he come from that town to that town itself? Correct? So this one will be 0. And because he moves out now from all different directions on the next day, okay, he can't be here. So a 0 will be here also. So before, after, both 0. Understood?
Okay.
Yep.
Achha, secondly, it also says that on Sunday afternoon, it comes back to town A. So we are going to apply the same logic here. In town A, we will put the rest all as 0. And town A, before the town A, we will put a 0.
Okay.
We can put a 0. And now we'll start. See, before and after is always 0. See, here also, because on the day before this, on Sunday, he was in town A, correct? The Sunday before that, correct?
Yeah.
So that's why there is a 0 after that, correct? So let's understand this. Now we will just keep on doing this. It's a very simple thing. For A, we will add up all the rest. We will get a 12.
Yeah.
For B, we will add up all the rest. So that's a 9 plus 4, 13.
Yeah. Yeah.
Okay. For the rest, all will be 13. Okay?
13 too. Yeah.
13.
Correct. Now we add all of this. We get 39 plus 12. We get a 51 here.
1. Yeah.
Yeah.
This 51 will come here. This 51 will come here.
Yeah.
The same 51 will come here. The same 51 will come
again.
here. Okay. All right. Now let's look at this. In this one, we'll add up. इसको छोड़ देंगे और इसके बाकी 3 51 ऐड करेंगे. So we'll get 153.
153. Yep.
Correct.
Yeah.
Yeah. For this one, we'll add up all the 4.
So we'll get 204.
Yep.
And the rest will be also again 153.
And then 153. Yeah.
Now we'll add up 3 153s. That gives you 459 and a 204.
Okay.
So we get 663 is yeah.
There are 663 combinations. Now in your dream also you could not have counted this, correct? If you wanted to count.
Yeah.
Correct. But did you understand the logic? Now same kind of problem you will see that it says passing the ball. Andy has a ball and at the end Charlie receives it or Andy himself receives it or whatever. But you understood the logic why we put the zeros and what we do, correct?
Yeah.
The logic is more important, correct?
Mm-hmm.
So that's about it for today then, because Yitishika has to go for gymnastics.
Yeah.
Bye.
Okay. So 22 yahan tak hua hai, Sudarshan, just make a note of this.
Yeah.
Okay, and 23 in the other one. So in this one we need to do 3 more questions, and that one we need to do 2 more.
Wait, in the seventh paper we did 23, and
Yeah, we did in the 7th paper we did 23, and in the 8th paper we did 22.
Yeah, there are only 25 questions, so we'll do that.
So we need to do 5 more questions.
Yeah.
Sudarshan, you should register for my contest, okay? It will be a good exposure for you. It's even more challenging than these questions. But anyways, you will be appearing for grade 5 and 6, correct?
Yeah, because I'm in 6th standard. No, actually,
So you're in 6th standard, na? So you'll appear for 6, grade 6.
Yeah.
Ask Yitishika how challenging the paper was.
It was very challenging.
How many questions do you think you got out of 25?
Most probably 16 or 17. I'm not even expecting about that. I mean, they got
16,
No, I
17,
didn't
if
get
you
the
got,
result
na,
yet.
if you get 16, 17, na, you will be like among the toppers. So don't worry. You wouldn't have got 16, 17. 16, 17, what you must have attempted maybe, or you think is correct.
Yeah, I think it's
Because the average score in most of the grades in my exam is out of 100 is in 30s or 20s.
What?
Oh.
Average score of all the students.
So in the seventh paper, like I had done it on my own, like I couldn't so for the seventh paper.
No. So let me be very, very honest. The sample papers are much easier
Yeah.
than my actual questions.
Because out of the seventh paper, I got like 19 out of 25.
So
And if that is easy, I know.
and secondly, another challenge is that because the 25 questions are there, there's a time constraint also. You have to complete in 1 hour.
Yeah.
In 1 hour.
Yeah.
What? So that's no fair.
What? No fair. Your SOF Olympiad give you 1 hour and 35 questions for 2
Yeah, I know.
questions.
You know what? Like, there's a secret. If you just have a calculator, you'll ace it. You'll ace it. Just ace it.
No.
Ma-
For 7th, 8th, I mean, I think from 7th only, they start giving 50 questions in 60 minutes. But it's
No, I
easier.
stopped doing IMO. Like, I know NSO is quite good, but IMO is just a waste of time.
Mm-hmm.
Okay, chalo then. ठीक है. Bye bye.
Bye.